Good morning. Today we will be talking about matrices. Give me 1 second though, real quick. Okay. Today we're going to be talking about adding and subtracting matrices. We have talked about matrices before when we were dealing with systems of linear equations. We could solve systems using matrices using substitution method. Today we're going to talk about the more versatility of matrices. Matrices can have a lot of usefulness for us. And a matrix, if you remember, is a rectangular array of numbers. Matrices are usually displayed within brackets. The dimensions of matrices are the numbers of rows multiplied by the number of columns in the array. Now, please, in real life, when you see these questions, this is more of a parentheses. It's going to be more of a real bracket. So I'm sorry I couldn't find a bracket for this size, but that's really what it's going to look like. They're not parentheses at all, okay? They're not parentheses at all. Every single value inside of this matrix is called an element, okay? Each number in a matrix is a matrix element. You can identify a matrix element by its row and column number. So for all of these values inside of here, okay, the first number that they have, the first subset number, is the actual row, and the second number is the column. So this right here, this is row 3, column 2, okay? Row 3, column 2. So that's the way we read. Let me get rid of all this. And the value that we have circled in blue here, okay, this is A12. Basically, this is located in row 1 and column 2. Please notice that columns support buildings. Think about it that way. Columns support roofs and ceilings. They're vertical. Rows are horizontal, like the horizon, okay? It's kind of like an X and Y axis. Columns are the Y axis, they're vertical, and rows are the X axis, they are horizontal. Now, as far as reading a matrix, okay, this matrix here, which we're going to call matrix A has 3 rows and 3 columns, and is a 3 by 3 matrix. It's read 3 by 3. You can write it as A, you just say matrix A, or you can say A 3 by 3. Remember, whenever we're talking about how you read a matrix, it's the rows is the first number, and then the column is the second number. So we got rows by columns. Please remember that, okay? If you remember that, you've got no problems with matrices because they're pretty darn simple. For example, what are the values of the elements located in row 1, column 3? What would row 1, column 3 be here? 1, yeah, that's absolutely right. That's row 1, first row, and column 3. Okay, row by column. What about for B? Row 2, column 2. Row 2, column 2. Row 2, column 2 is 5. Row 2, column 2. Awesome. Does that make sense? Okay, awesome. Good stuff. Now, what is element 1 by 4 here? What is element 1, 4 here? 1 by 4.
4.
Okay, row 1, column 4. We're talking about 4. Excellent. What would, we'll do it in blue, what would element A3 times 3, 2 be? Okay, we're talking about row 3, column 2. We're talking about that right there, negative 4. Does that make sense, y'all? Okay, awesome. Now, when dealing with matrices, you are allowed to add them as long as they have the exact same dimensions. Simply add or subtract corresponding elements and rewrite each sum or difference into a matrix of equal dimensions. You have to make sure that they're equal dimensions. A 4 by 5 cannot be added to a 5 by 4. It cannot. You don't have the same elements. A 3 by 2 cannot be added to a 2 by 3. They don't have the same elements. They have to have the same exact dimensions. So in this case, what kind of a matrix is A? Remember, it's rows by columns. So this is a 2 by 3. Remember, rows by columns, my friends. And what would be, what kind of a matrix is B? What are the dimensions of B? It's also 2 by 3. Rows by columns. Okay? So now, we know that these are the same dimensions. So let's go ahead and do some calculations. What is A plus B? Now, you guys are pretty good. You guys are pretty advanced. So what I would do is I rewrite a matrix. I know that my matrix is going to be a 2 by 3. It has to be. So I'm adding here, okay? I'm going to do this in my head. If it confuses you, I'll do it out the long way. But what's 4 plus 3? 5 plus 2. Negative 3 plus 7. Negative 2 plus 6. 0 minus 3. And 5 plus 1. That's it. You're done. Literally. It's that easy. It's that easy. Sir. That's exactly what we just finished doing. Yes, sir. We added the matrix. Thank you, sir. Now, let's try B minus A. Now, in this case, guys, let me just show you real quick. Let me just go ahead and clone this for a second to help us out here. Okay. Let's go ahead and do this. Let's go ahead and get rid of that for a second. And get rid of that for a second. Okay. Now, in this case, guys, I've got B minus A. So whoever said that is perfectly right. Thank you. You have to distribute the negative. That's exactly correct, guys. So what I would do when I have a situation like this, I would first make this a positive and distribute the negative to everything inside of here. So that would become negative, that would become negative, positive, positive, 0 doesn't matter, and then that's a negative 5. Now, I would add them. All right, it's exactly the same as when we were adding polynomials or subtracting polynomials. When we were subtracting polynomials, you wanted to distribute that negative before you add it. So now it's Mickey Mouse. 3 minus negative 4, negative 1. We got then a negative 3, 2 minus 5, 7 plus 3 is 10, 6 plus 2 is 8. Come again? Ah, yeah, negative 3. Thank you, son. Row 1, column 2. 6 plus 2 is 8. Negative 3 plus 0 is negative 3. And 1 minus 5 is negative 4. Done. Bye-bye. Gone. Have a good day. Pretty easy, right? All right, now, same thing. A plus B. First of all, what are the dimensions of A in this case? Guys, this is a 3 by 2. Please be careful. It's rows by columns. And what are the dimensions of B? They're also 3 by 2. Rows by columns. Please be careful. All right, so let's create the sum matrix of A plus B. So what do we got? Negative 27, yes. 46, yes. Negative 15, yes. Negative 6, awesome. Awesome. And 20, great. Now for B. Remember, we're doing B minus A. So we're doing negative 12, negative 6, 20, 18, negative 9, 8, minus negative 15, negative 9, negative 11, 28, 3, and 12. So what do I have to do here first? Distribute the negative. That's exactly right. Make that a positive. And multiply everything by a negative. So what's my final matrix going to be here? 3, negative 10. 3, negative 12. 31. And negative 4. Fantastic. Awesome. It's pretty easy, right, guys? Awesome. Awesome. Next. Now we know how to add and subtract them. But equal matrices, okay, also have the same dimensions and equal corresponding elements. So you can find unknown matrix values if you know that two matrices are equal. So what you would do here is element by element, okay? The element of one matrix is going to be equal to the element, the corresponding element in the other matrix, okay? You set them equal to each other just like a regular equation. So for example, don't stress about this. Isn't this element 1, 1? Isn't this element 1, 1? Well, 8 equals 8, correct? Yeah, we're done. That's already set up. Okay, let's check out 4x plus 2. Isn't that element 1, 2? Right? Row 1, column 2. That has to be set equal, or that has to equal negative 14 because that's element 1, 2 in the second matrix. Does that make sense so far? So I'm going to have 4x plus 2 equals negative 14. Subtract 2 to both sides. 4x equals negative 16. X equals negative 4. Now I know what x is. You guys with me so far? Okay, now, that is element 2, 1. That has to be equal, set equal to element 2, 1 in the other matrix. So I've got 3y minus 4 must equal 5. Add 4 to both sides. 3y equals 9. Divided by 3. Y equals 3. We're done. And then the last elements. What are the last elements, Mr. Morrow? Well, the last elements, that's element 2, 2, which has to be equal to 2, 2. And 15 does equal 15, so we're good. So the answer is x equals negative 4 and y equals 3. Why are those the answers? Because that's what they asked me for, sir. Find the values of x and y. Thank you for asking. Good job. Yes, sir. You would have to do all the work, yeah, unless you could do it in your head. No, I don't. You don't have to circle everything I circled. I circled what I circled because I'm teaching you how to do it, sir. Yes, sir. So the rows and columns are the same. Don't worry about it. As long as the dimensions are the same, then you can either add, subtract, or set matrices equal to each other. Yes, sir. Okay, you mean like this? Okay, he's just asking for a more complicated one, and we got it right here. Okay, yes, sir. Okay, I don't understand what that means, conflicting values, sir. If they're not really equal, then you can't set them equal to each other, and then you would say no solution. Thank you, sir. So in other words, if here I have a negative 9, and that's element 1, 2, if this equaled, for example, a negative 8, would those be equal? Could you proceed with this matrix? Could you proceed with this matrix? No, it would be no solution. Okay, so yes, if the elements are not equal, then they're not equal matrices, and there would be no solution. But in this case, you can tell right off the bat that element 1, 2 is equal to element 1, 2, so these are going to be equal matrices. And of course, we have w plus 2 equals 6. Don't have to do much work there. W would equal 4. Y minus 9 equals 3y plus 7. Okay, yeah. Subtract the 7 and add and subtract the y, so you're going to have 2y equals negative 16. So y would equal negative 8. And then, and that's it. We're done. What about this, Mr. Moore? Well, we already know what W is. So what would the value of this element be? What would the value of that element be, though? Guys, what would the value of this element be? 33. Thank you. Don't you know that 4 W is 4? 36 minus 3 is now 33, guys? Okay. Ah, but wait a second. Okay, yeah, look. That's why you have to test this. So this would be?
No solution.
No solution.
We know what that is.
Very good. So do not take for granted that you find a variable early in the matrix. You could have a no solution. You have to test these things. And that's what we just finished answering. Okay. Next. Okay, now here we get to a little bit more complicated stuff, but just write out, would be my opinion, write out every part of this equation. So let's first start with elements 1, 1. Okay? You're going to have x minus 14 equals 5. Next one, let's start with 1, 2. Negative 6 minus a negative 8, that's 14. Wait, no, that's plus. Hello? Negative 6 plus 8 is 2, and 2 equals 2. So far we're good there. Everything works there. Let's go to 2, 2, 1. We got 4y minus 2y, so that's y. 4y minus 2y is 2y, which equals 26. And the last thing we got, 0 minus 4w plus 2 is 4w plus 2. And you got 4w plus 2 equals negative 14. Okay, so now it's Mickey Mouse. You just solve. Yes, it would be. Good catch. Good catch there, guys, because you have to distribute that negative. Excellent. So negative 4w minus 2 is equal to 14. Excellent. Excellent job. Well done. So x is going to equal 19. Y is going to equal 13. And add the 2, divide, w will equal negative 4. Does that make sense, gentlemen? W equals negative 4. No, this is 6. Guys, you add the 2. You add the 2. Wow, I'm off today. So yeah, negative 4w is going to be negative 12. Yes. See, I shouldn't do it in my head. I always tell you guys not to do it in your head, and what do? Do it in my head. And look what happens. You get it wrong. You can't beat the system. Got to do all the work. Thank you. Good catch there, guys. Does that make sense, guys? Because we're good. We're golden. All right, my brothers. We'll do some practice now. Thank you very much for a good lesson.